In this video, we want to talk about the book Fooled by Randomness by Nassim Nicholas Taleb. In chapter 10, Taleb talks about nonlinearities in life. We want to start with the following quote: "The drop that caused the water to spill." In context of the first example given in this chapter, we can change the quote to "the sand grain that caused the sandcastle to collapse." The example is as follows. Taleb is building a sandcastle. It grows steadily as he adds more and more sand. But then suddenly the whole construction collapses, so the linear and steady building process was stopped drastically in a nonlinear manner. The point is that a small change, namely adding just a bit more of sand, can have a huge impact, in this case the collapse of the castle. A mathematical example is given by the Polia urn. The idea is as follows. We start with an urn with one black ball and one white ball. After every draw, we put the ball back in the urn and add an additional ball of that color. The consequence is that the probabilities change over time. In an ordinary sampling with replacement, the probability stays the same for each draw. In contrast to sampling without replacement, the probability of drawing a color increases by drawing that color. This principle can be interpreted as the rich are getting even richer or the poor are getting even poorer. Because let's say we draw 10,000 times and each time we draw black we get $1. If you are lucky the first few draws and only have black, the probability of having even more blacks in the following draws is pretty high. Whereas if you start with only red, the chance of making a big profit is rather small for future draws. We used R to run a Monte Carlo simulation of this process. So we generated 20,000 games, and in each game, 10,000 balls were drawn from the urn. If we focus on the number of black balls in the end, which corresponds to the profit in our example, we observe a very big spread. The range is from 0 to 10,000, which means that in one scenario it actually happened that all 10,000 balls were black, and in another scenario it happened that all balls were white. It sounds very unrealistic, but the probability of observing only black can easily be calculated as follows. The probability to draw black in the first round is 1 over 2. Conditioned on drawing black in the first round, the probability of drawing black in the second round is 2 over 3, since there are 2 black balls and 1 white ball in the urn. Adding another black ball leads to 3 black balls and 1 white ball in the urn, and a corresponding probability of 3 over 4 for drawing black. If we continue like this, we end up with a probability of n over n plus 1 for the last draw, because conditioned on observing only black before, there are n black balls and 1 white ball in the urn. Therefore, the probability of observing only black is given by n factorial over n plus 1 factorial, which simplifies to 1 over n plus 1, or in this case, to 1 over 10,001. Likewise, the probability of only white is 1 over 10,001. In 20,000 games, it is therefore not that unlikely to observe. This plot shows the distribution of the profit after 10,000 draws. One can show that the distribution is uniform with range from 0 to 10,000. Another interesting aspect of this experiment is analyzing individual games and focus on the proportion of black balls after each draw. We typically observe a lot of variability at the beginning, but then the proportion stabilizes as the number of draws increases. However, the different games converge to different values. We pick the following examples. The plot shows the proportion of black balls after each draw for the first 1,000 draws. It is essentially constant afterwards. We can observe that it converges as the number of draws increases. We can also see that for this particular game, the proportion of black decreased over time. So this corresponds to the case where the poor are getting even poorer. In fact, this one resulted in 221 black balls at the end, so a profit of $221. But of course, this is just one individual game and it could also look the other way around, as shown in the next plot. So this example corresponds to the case where the rich are getting even richer, and for this particular game there were 9,775 black balls in the end, so a profit of $9,775. In some cases, the development is not as clear and easy as in the previous two cases. Sometimes the proportion converges to neither 0 nor 1. Even though there is still variation in the beginning, it never takes the extreme path to a proportion close to 0 or 1. It sometimes converges to a value close to 0.5. The last game we analyzed shows such a development, and it ends with 5,330 black balls, so a profit of $5,330. Overall, the analysis showed that individual games of the Polia urn differ a lot. The first part showed the uniform distribution at the end, and the second part focused on individual games and on how different the development can look.